Okay, so we are looking at complex numbers today, operations with complex numbers also. So I'm going to start with what a complex number is. A complex number is a real number plus an imaginary number. So they usually set this up as A plus BI. So A would just be some ordinary number, and then BI would be some multiple of I. 3i, 5i, negative 10i, that sort of thing. So this is what it looks like. So the real part, the imaginary part, it can have a plus sign or a minus sign in the middle depending on whether the imaginary part is positive or negative. So I'll give you some examples of what complex numbers look like. So I can have 5 plus 2i. You can have 3 minus I. Negative 2 plus 4i. So generally speaking, they always put the real part first and the part with the i's, which is the imaginary part, second. So these are just examples of what complex numbers look like. Scoot that up. All right, so we are going to do 1, 2, 3, 4, 5, 6, 7, 8 examples of operations today. We're going to add, subtract, and multiply. So if you want to figure out how to space this out, you can. I'm going to go ahead and do example. Actually, let me do this. Let's set up some categories. So over in your margin, let's write adding, and that'll be for the first 2 examples.
Yeah.
So a lot of times if you have the real and the imaginary part for both of these, they treat them like a binomial, like it has 2 pieces, and so they'll use some parentheses. So they'll have 8 minus 5i plus 2 plus I. And really, this just goes back to some basics of algebra. When you're adding, you just add the like terms. So 8 and 2 are the real parts, so you can add those and get 10. And then remember that this minus sign goes with the 5i, so the minus 5i and the plus 1i would go together, and it would be minus 4. So you just go ahead and change that to a minus sign since it's negative 4. You get 10 minus 4i. So 8 plus 2 is 10. Negative 5 plus 1 makes negative 4. So let's do one more adding problem. So let's do negative 3 plus 7i plus 2 minus 4i. So our real numbers go together. Negative 3 and positive 2 adds up to what? Negative 1, and then I have 7i, and then negative 4i.
3i.
So that would be 3i. And if it comes out positive, we use a plus sign to separate this. So adding, basically, I'm just going to put a little note out here. You're just combining
So that's just
like terms.
addition.
Right. It gets a little bit more interesting when we get down to multiplying, but adding and subtracting are not too bad. Okay, so for the next piece, we'll do subtracting. I'm just going to write SUBT to stand for subtraction. With subtraction, there is an extra step. You wouldn't think there would be, but there is. So we're going to start with 4 plus 7i in parentheses minus, in parentheses, 2 plus 3i. So everything in the parentheses is positive, so you can kind of get the idea. So when you're subtracting this whole thing, this subtraction gets distributed out. So the step that I like to do next is to go ahead and distribute that and just take the parentheses off. So I have 4 plus 7i, and this would become minus 2 and minus 3i. So both of these change signs because that minus sign is here. And then you can combine like terms.
Question?
Yes?
So why wouldn't it distribute to the... Never mind, I got it.
Okay, got it?
Yep.
So basically we just distributed this out, rewrote it, and we took the parentheses off. You could put put parentheses on there if you want to, but once you distribute, usually you leave it off.
Equals 4i.
So I have 4 and negative 2 that go together, so that's 2. And then 7i minus 3i gave us right. That does come out 4i.
Also, something I just noticed about this question in particular, if you just subtract the ones originally, it makes
right. So let's see what happens when we add some negatives. So yes, this one you might be able to do in your head without writing it out, but they're going to get more complicated, yes. So let's say I have, for our next example, negative 2 plus 5i minus, in parentheses, 3 minus 4i. So when I distribute this out, some interesting things are going to happen. The first part you can just copy, negative 2 plus 5i. And then when I distribute the minus to the 3, it just becomes minus 3. And then I have minus negative 4i. So I like to go ahead and rewrite that as positive 4i. If you're trying to do this in your head, negative 2, keeping track of all the minus signs does get tricky. I recommend everybody, this is how you show your work. Oh, and I put an I on the 3. I didn't mean to do that. Sorry. So it was just minus 3. There was no I. So negative 2 and negative 3 go together. Just negative 5, 5i, and 4i make 9i. So we get negative 5 plus 9i. So you're basically just doing 2 subtractions.
And I just solved that one just by looking at it too, because if you add...
Good. But this is how you show me the work. So I need everybody on your assignments to write this part out. With adding, I'll kind of let you get away with doing it in your head because there's not much to write down. With subtracting, I do want to see this step on your papers just because that helps me make sure that you're getting the signs right. All right, so for multiplying, that's going to take a lot of room because we're going to do 4 different examples of different kinds of multiplying. So I'm going to put mult over here for multiplying. And we're going to start with one that's just simple distribution. If I have 4, and then in parentheses, negative 3 plus 7i, there's just a 4 sitting out there, and this is in parentheses. It's just simple distribution. So 4 times negative 3, negative 12. 4 times 7i would make 28i. So it's just simple distribution. It gets a little bit more exciting if you have to distribute imaginary numbers with I. So let's do one of those. Let's say I have 3i times 5 minus 4i. So I'm taking 3i times 5. What will that be?
15i.
15i. And then I'm going to take 3i times negative 4i. So I'm going to have negative for sure, positive and negative.
Negative 12i. And so then you
it's not I though, it's I times I, which is I squared. Now remember, so remember that I squared equals negative 1.
15i minus 12, that's it.
Minus 12 times negative 1, which makes it 15i plus 12.
Is I squared?
I squared is negative 1. Now, normally on the answer keys, they're going to put the real part first, so I'm going to rewrite it one more time. 12 plus 15i is usually what the answer key is going to say. Is it a huge deal? To me, it's not because you're adding both of them together, but technically complex numbers are always real plus imaginary, so this is usually how you're going to see the final answer written. I would take this. You still have all the right numbers. They're all good there. So anytime you multiply an I times an I, a lot of times people just write down I, they forget it's I squared, so that's something we're going to have to pay attention to. And you also need to remember that I squared is negative 1. So that's just something that you have to get rid of.
Say if we have a standardized state test, would we have to put like the first one as being...
So most of your standardized tests that this would be a multiple choice. So you just would look at however it was on there. With your SATs, I don't think they're going to give you anything like this on the open-ended because you'd have to code in the I. My guess is this would be on the multiple choice part. So that makes it a little easier. And they do occasionally slip in 1 or 2 of these. It just depends on which test you end up taking. All right, so now we're going to look at a couple where we have some massive distributions. So we have 4 plus 2i, and and 3 minus 5i. So we have to use the FOIL method for this. Firsts, outers, inners, lasts. So basically you start with whatever's on the left here, and the first are taking the first in this parentheses times the first in that parentheses. So 4 times 3. 4 times 3 is 12. Then I'm going to take this 4 and distribute it to negative 5i. So 4 times negative 5 is negative 20, and it just has a regular I on there because this was just regular 4. You guys writing all this down?
And then you would distribute 2i.
And then we distribute 2i.
And then it would make it
Yeah, so we'd have plus 6i. Hang on. So 2i times 3 is 6i, making sure everybody's having a chance to get this down. And then the very last one's where you have to be careful. So I have 2 times negative 5, so that's negative 10. And I times I is I squared. Okay? So basically this is going to be negative 10 times negative 1, which will make that positive 10 over here. And I have the 12 from over here.
And then you combine like terms.
And then you combine like terms. And I'm just going to go ahead and rewrite it all like that. So you have 12 and 10. So 12 and 10 is 22. Negative 20i and 6i is how much? Negative 20 and positive 6.
Negative 14.
Negative 14i. Yes, this term down here no longer has an I. When you have I squared, it goes away and becomes a regular number. You will always have only 2. Sometimes something may cancel out and you may only get the real or the imaginary part. That is possible. But you will have at most 2 terms, the real part and the imaginary part. You will never have anything more than 2. If you do, then there's something else that can be simplified. So just one more of these and then we'll move on to practice problems. So negative 3 minus 7i.
Are we not going to do division?
And not today. Division's its whole lesson by itself. It has a lot of other things to do with it. All right, so I'm going to take this negative 3 times this 5. What's negative 3 times 5?
Negative 15.
Negative 15. And then negative 3 times negative 2i
Positive 6.
is positive 6i. You have to be really careful with the signs. Negative times a negative is a positive. Then negative 7i times 5.
Negative 35i.
Good. And then negative 7i times negative 2i. Positive 14i squared. And if you think about it, this is negative 1. You could go ahead and write down negative 14 here if that makes sense to you. I like to go ahead and write this step just so people understand where it's coming from. I squared always gets replaced with a negative 1. We never leave it I squared when we're talking about imaginary numbers. So I'm just going to copy all of this down here and then we'll combine like terms. So negative 15 and negative 14 would go together.
Negative 54. Yeah, 24. 29.
29. You're having a little bit of issues adding today.
No, I thought we were at the end.
Oh, and then you're doing this part. Okay, so 6 and negative 35 is also negative 29, and then that'll have an I. And so on the answers, they put the real part first, imaginary part second, and that's it.